So a derivative is the instantaneous rate of change. Instantaneous rate of change of a curve. We could also say it is the slope of the tangent line to the curve at any point A. All right, this might sound a little bit like gibberish, but we will go over what all of that looks like and what that means. Before that, though, let's look at notation. So, notation. There's a few different ways you will see the derivative notation. So one of them is dy over dx, which is a derivative. And this we read as the derivative of y in terms of x. Okay, you might also see y prime or f prime of x. That's just a shorthand way of writing a derivative. And like I just said, we pronounce that y prime or f prime of x. Okay. So go ahead, take a second to write that down, and we will continue. So just in a broad sense, let's talk about what a derivative is and what all of those words up there mean. So if we're going to look at just a parabola. So f of x equals x squared, and the derivative of that, or f prime of x, would be 2x, and we'll learn how to take the derivative shortly. But let's look at a graph of x squared. So 1, 2, 3, 4, 6. Okay, I'm just going to plot a couple of points. 2, 3, 4. Okay, so here's just a basic parabola. So what the derivative is telling me is at any point what the slope is at that specific point. Because obviously this isn't a line, so the slope doesn't stay consistent and it's constantly changing, but I can find the slope at any given point. So if I wanted to know what the slope is when x equals 1, then I can plug in 1 to the derivative, and it would be 2. So if I look here at x equals 1, and then I use the slope of 2, so up 2 over 1, or down 2 over 1. This is the tangent line at 1, and the slope of that tangent line is 2. So at this point, the rate of change is 2. Okay, if I look at the slope at 2, so the derivative at 2, we would have 2 times 2, which equals 4. So at this point, and you can see it's getting steeper, so it makes sense that the number is higher. At this point, the slope is 4. So again, if I use slope, we're going to go up 1, 2, 3, 4 over 1, down 1, 2, 3, 4 over 1. And if we connect those, preferably with a ruler, but I don't have a ruler on this thing, then we have that the slope here is 4. So hopefully you can kind of see what the derivative allows us to do is find this rate of change all the way along the curve, which helps us see what's happening with the curve. Let's look at just one more so you can see. We could find it at 0, which would just be 0. And we should know that when the slope is 0, that means there's a horizontal line. So even right here, this line would have a slope of 0. Okay, So these approximate the curve. And that's just broad definition of what a derivative is. All right, so now that we know what a derivative is, let's go over the first rule of how to take a derivative. So our first rule is power rule. If we have f of x equals ax to the n, then the derivative of f of x would be n times ax to the n minus 1. So what we're doing is we are taking the exponent and moving it down, and then we're subtracting 1 from the exponent. Okay, so let's do a couple of these. They're not too hard. So, example, if we want to find the derivative of the following. All right. So first one, if f of x equals x to the 10th, then we're going to follow this rule. So we're going to take the 10 and move it down front, and then subtract 1. So f prime of x would just be 10x, and then 10 minus 1 is 9. And that's your derivative. Okay, let's try another simple one. So f of x equals x to the, let's do a negative 5. See if you can do it on your own. So same thing, we're going to move this down. So f prime of x equals negative 5x, and then negative 5 minus 1 would be negative 6. And then let's go ahead and write this properly. Negative exponents, we move to the denominator, so this would be negative 5 over x to the 6th. A few more. What if we have f of x equals 1 over x to the 3rd? Okay. So like we kind of just talked about, we can rewrite these. We always want everything in the numerator if possible. So I can rewrite this as just x to the negative 3. And then it's just like the last problem. So we're going to take the negative 3, move it in front. F prime x equals negative 3x, subtract 1, so to the negative 4. And then writing it properly, negative 3 over x to the 4th. We also could have roots. So if we have f of x equals the cube root of x squared, then hopefully you remember how to rewrite these, but if you don't, I'll show you. So we have f of x, and I can write this as x to the 2/3. So quick little side note, if you forgot how to do this, anytime you have n root of x to the m, you can write that as x to the m over n. Okay. Okay. So going back to this, we're going to take the fraction and move it down, and then subtract 1. When you have fractions, I always just write it as a fraction when I'm subtracting 1. So the denominator is 3, so I'm going to subtract 3 over 3. Okay, so we have f prime of x equals 2/3 x to the 2/3 minus 3/3 is negative 1/3. Writing that a little better would be 2 over 3x to the 1/3. And then we can also put that 1/3 back in root form. So 2 over 3, and this would be the cube root of x to the 1st. So just cube root of x. So in this video, we learned a broad definition of what a derivative is and what that means. And we also learned our first derivative rule, which is the power rule. Thanks for watching.